Hey everyone, today we're going to be talking about area, perimeter, and circumference. The plan for this video is we're going to carefully define these shapes, which of course you've seen before, but we're going to define them in such a way that we can use them in mathematical problems. Since mathematics is a very rigorous and well-defined field, everything has to have a set and standard definition. Just as a challenge, try describing any of these shapes to yourself without drawing a picture. So for instance, how do you talk about what a rectangle or a triangle or a circle are without drawing it and pointing at it and saying, well, this is what it is? So let's talk about rectangle anatomy. The definition of a rectangle is we have a four-sided polygon whose opposite sides are the same length and whose angles are all 90 degrees. Using this definition, we find that a square is just a special case of rectangle where all sides are equal. In a general setting, we would label the sides by L for length and W for width. It doesn't matter what you call what as long as you're labeling opposing sides by the same letter, and you're consistent throughout your whole process. Once we've done this, we can describe the perimeter. Think of perimeter as walking around the rectangle and then calculating how far you've walked. Since we have labels for all of our sides, we can define the perimeter as L plus W plus L plus W, which we'll just call 2L plus 2W. In general problems, we typically denote perimeter with a capital P. Next, we can define the area. The area is going to be the space that is inside the rectangle, and it's just L times W. So these formulas hold true for any rectangle that you're looking at. Let's go ahead and start looking at some problems. Suppose that I'm fencing in a rectangular space that has an area of 50 square feet, and one side is twice the length of the other side. My goal of this problem is to find the exact measurements for the length and the width of the rectangle. I can start out by drawing a picture. I know my area is equal to length times width, which is equal to 50. If this were all the information I had, then I'd be stuck, but I do have this other condition that one side of my rectangle is twice the length of the other. I'll choose this labeling for my rectangle, where L denotes my longer side and W denotes my shorter side. This problem stipulates that my longer side is twice the length of my shorter side. So, in mathematical terms, this means that L is equal to 2 times W. This relation brings me from a two-variable problem to a one-variable problem, because I can express L in terms of W. This is going to allow us to solve for W, which will then help us solve for L. I'm going to take my area formula, L times W equals 50, and substitute the L for 2 times W. Doing this gives me L times W equals 2W times W equals 2W squared equals 50. Now I'm going to zoom in on the equation 2W squared equals 50. So to solve for W, I can divide both sides of this new equation by 2, giving me W squared equals 25, and then taking the square root of 25 gives me an answer of W equals to 5 feet. Now that I know the value of W, I can find out the value for L because L equals 2 times W. Therefore, L is going to equal 10 feet. Thus, I have my length and my width of this rectangle, and I'm done. For our next problem, suppose that I have a rectangular floor that has a perimeter of 40 meters, and the large wall is 3 times the length of the short wall. Find the area of this floor. Like before, I'll start out by drawing a picture. I'll let W denote my short wall, and L denote my long wall. I'll go ahead and list out what I know from this problem. By the definition of perimeter, we know that P is equal to 2L plus 2W, which is equal to 40 meters. And I also know that L is equal to 3 times W because my long wall is 3 times the length of my short wall. Now since I'm able to write L in terms of W, I'll take my perimeter formula and then I'll solve for W just like I did in the previous problem. Doing this gives me P equals 2 times 3W plus 2W, which sums to 8W, which equals to 40 because 40 is our perimeter. Again, I just replaced L with W because I know how to write L in terms of W. This brings me down to a one-variable problem, which is easier to solve. Now I can zoom in on the equation 8W equals 40, divide both sides by 8, and find that W is equal to 5. And now I can plug this information back into L and find that L is equal to 3 times 5, which means that L is equal to 15 meters. Now that I have L and W, I can solve for area, which is 5 times 15 equals 75 meters squared, and we're done. Now we'll talk about triangle anatomy. By definition, a triangle is a three-sided polygon with flat edges such that all the angles sum to 180 degrees. In a general setting, triangles are pretty weird because if all I have to go on is this definition, I really don't know much. They don't have the same rigid structure as a rectangle, so you get fewer formulas. So what we should do next is start classifying different types of triangles that we can have. Such a classification will help us solve triangle problems in a more efficient way. One type of triangle is called a right triangle. We say a triangle is a right triangle if one of the angles is equal to 90 degrees. We say a triangle is an acute triangle if every angle is strictly less than 90 degrees, which might look something like this. We say a triangle is an obtuse triangle if one of the angles is greater than 90 degrees. So the triangle at the top right-hand corner of the screen is an obtuse triangle because the top angle is well over 90 degrees. So generally, obtuse triangles are short and wide. The next kind of triangle is called an isosceles triangle. Such a triangle has two sides of equal length. Generally, these triangles are thin and tall. And last, an equilateral triangle is a triangle where all three sides have equal length. Equilateral triangles are also acute triangles because this kind of structure forces every angle of this triangle to be 60 degrees. So I can offer a vague definition of a triangle in terms of its perimeter. The perimeter doesn't really have a nice formula like it does for a rectangle, so all I can really say is that the perimeter is the sum of the lengths of the edges of the triangle. The only time you can say more about the perimeter is if you know more about the triangle. But I can define some stuff about the triangle. What I can do is pick an edge, I'll call that edge B, I'll call that the base of the triangle, and then what I'll do next is draw a dotted line from the angle that is across from the edge that I chose as my base, and I'll call that the height of the triangle. So you can choose any edge as your base that you want, your height just has to be directly related to that base, like I've drawn in the picture. And then once I've selected my base and my height, I say the area is equal to 1/2 times the base times the height, and this is true for every triangle. Let's look at some examples. Suppose that I have an equilateral triangle with perimeter equal to 12 and area equal to s squared over 2, where s is equal to 1 of the length of the sides of my triangle. Our goal in this problem is to find what a is exactly. Note, this is not a general formula for area, this is just what area equals in this particular problem. I'll go ahead and set up my picture. But since I have an equilateral triangle, I know that every side has the same length. So once I label one of my sides as s, I can label the other sides as s as well. Since my perimeter is equal to the sum of the length of the edges of my triangle, I know that p is equal to s plus s plus s, which is 3s, which equals to 12 because of the stipulation of the problem. Now I can solve for s with the equation 3s equals 12, and I find that s is equal to 4. Now that I have information on s, I can plug this in to my formula for area. Therefore, a is equal to s squared over 2 equals to 4 squared over 2, which is 16 over 2, which is 8. Thus, I've solved the problem because I found that the area of this triangle is equal to 8. Usually math problems involving measurements will give you some kind of unit of measure. I didn't put those here, but if I was talking about my perimeter in terms of feet, then my answer would be in terms of square feet. If my perimeter was in terms of meters, then my answer would be in square meters, and so on. For our last topic, we'll talk about some circle anatomy. By definition, a circle is a closed, round figure equally spaced around its center that we call an origin. So when I say the circle is equally spaced around the center, I mean that if I were to draw a straight line from the center to the edge of the circle, no matter what straight line I draw, they're all going to have the same length. Since they're all the same length, I have this well-defined definition called a radius. A radius is just going to be the distance from the origin to the edge of the circle, which I usually denote with r. So the radius is going to be equal to the length of any of these spokes that I've drawn. Now when talking about the perimeter of a circle, we have a special name. That is called the circumference. The circumference is my length around the circle. This is harder to measure because it's a curve, but the circumference is nicely defined as c equals to 2 pi r, where r is our radius. So you might know pi as this 3.14 ... decimal number that never ends. It comes from its derivation of the relation between the radius of a circle and its circumference. We won't go into that too much, and I don't expect you to know how to calculate pi off the bat, so the way that you write answers is just simply leave pi in your answer or just use a calculator. So that's why our circumference is written in terms of 2 pi times r, because that is as simplified as it needs to get. Lastly, since I have circumference based on radius, I can have area, which is also based on radius. The area, in other words the space inside the circle, is defined as a equal to pi r squared. So really, the radius of a circle defines everything there is to define about the circle. As long as you have the radius, you basically know everything you could ever need to know, at least about the circle. Now let's talk about a problem. Suppose that a runner takes 5 laps around a circular track that is 1 mile in radius. How many miles did they run? Like always, I'll draw a picture. I'm going to draw my circular track, and I'm going to draw this blue line to denote my radius, which I know is equal to 1 mile. Now I know that my runner took 5 laps around this track, which means that his total distance will be 5 times the circumference of this circle, since running around the circle once means that I have traveled the length of the circumference once. So running around it 5 times means I need to take the circumference and multiply it by 5. Since I know my radius is equal to 1, I can calculate the circumference, which is 2 pi r equals 2 pi times 1 equals to 2 pi. Multiplying this by 5, I get an answer of 10 pi, and when I put that into a calculator, I get that the runner ran approximately 31.42 miles when I round to the nearest hundredth spot. So as additional exercise, go try to beat the runner. See if you can run more than 32.4 miles. If you can, then you're really healthy, because I definitely can't.